So in this video, we're going to go ahead and take a look at the geoprocessing tool Buffer. What Buffer essentially does is it will add a inflated shape that mimics the shape of the object that you're analyzing and increasing the area around it. Practical uses for something like this would be, in our example here, we've got this river system. We've got our polygons and some points. It's just a mock-up, nothing too serious. Long story short is let's say for the river system, we want to capture all the points within, 10,000 meters of this river. Okay, one of the easier ways to do that is to create a buffer, all right, around the river, or both of these, right, and then find with the buffer what points actually lie within that region. With ArcPro, you're going to find most of your map stuff under this map button here. Under analysis is where we begin to find our geoprocessing tools. Okay, subsequent videos should cover this as well. What you'll end up seeing is this region here, which is the quick drop down tab. Okay. These are tools that the authors of ArcPro have decided are your quick access or something like that tools. I want to get everybody in the practice of not necessarily using this button. Okay, what we want is to stick with using our Arc Toolbox button. Okay, so we've got Toolbox, and it will default when you first open it to this Favorites button. Okay, and that's going to provide, again, a list of, as far as they're concerned, commonly used geoprocessing tools. All right. Again, we want to get in the practice of finding where they are in actuality. So, analysis and tools, and then our full list of toolboxes of everything are listed under here. So we have just generally the default tool set for ArcMap has this many different types of tools depending on what process you're looking for, editing, even stuff as specific as maritime tools. But what we're looking for is basic stuff. Under analysis, you'll find a different array of subject-related tools, and under proximity, we find buffer. Let me stress, it's the same tool as listed here, and the one under favorites as well. It's the same tool. So we'll go ahead and double-click buffer, and most of the Arc tool layouts are very similar. The first question you'll be asked in general is what file do you want to analyze, and what do you want to name the new file? All right. The rest of these are specific to the tool buffer, but for the most part you'll see these listed out. Okay, and there'll be multiple ways to load the file. All right, so there's a drop-down tab, and this lists all the files that are present in the map here. All right, or you could use the browse and open something up from a different folder or something. Okay, we're going to go ahead and buffer our mock-up rivers. All right, things for class to always remember. The computer's going to try to send it to a default geodatabase. If you see it listed here, let me see if I can bring it up, where it says default geodatabase here. All right. Make sure in class we always send this to S drive. All right. We want to name it something that we can remember. I would say rivers buff example or something like that. Just make sure that it is going to S drive and you do not leave it as export output or something like that. Okay. So other options within buffer. Okay. This tool is often underutilized. Multiple different things can be added to buffer to make creative and interesting outcomes. Okay, so distance would be how big do you want the buffer to be? All right, and units we can set to either linear units, like I want my buffer to be 15,000 meters. All right, or we can use a field that has things already defined. All right, we will go use field, and I'll show you what I mean in a minute, but let's just use linear unit for now. And let's pick our linear unit, and we'll go with meters. All right, we want to say we want our buffer for both of those rivers to be 15,000 meters. All right, things to consider, side type. All right, we could do for line files, okay, we could do full, so it's a full buffer. All right, and we could buffer just the left and right sides of the lines. All right, if you're getting confused here, these drop-down tabs have these little information windows. You see listed here, left for line input features. Buffers will be generated on the topological left of the line. Not valid for polygon because what is left in a polygon? Same idea with right. All right, since we're going to do lines, all right, I'm going to run a few of these, but we'll start with full. All right, end type. Again, we can check out what these things are saying. The end of the buffer will be round in the shape of half a circle. All right, flat, the buffer will stop. All right, possible uses for a flat-ended buffer, and again, I'm going to go through all these. It'd be like a road network or something like that. We don't necessarily need a rounded end if your road stops somewhere. Okay, we don't necessarily need the buffer to go all the way around. Methods, planar. Do we assume our buffer will be created on a two-dimensional plane, or do we actually begin to respect the shape of the Earth? This question becomes something that we would become familiar with the farther along we are as spatial analysts. In general, if you're doing something on a city size, county, or something like that, planar is probably okay. Geodesic would begin to become a thing when we're talking about like transcontinental buffers. So if you wanted to buffer the East Coast or the entire coast of the Western Hemisphere or something like that, you might want to begin to consider the actual curvature of the Earth with the geodesic function. This is just an example, so we're going to start with planar. And dissolve, we're going to pick dissolve all. All right, we will show you the contrast between these. When you have multiple objects being buffered, do they need to be separated as buffers? So with the points here, we have 100 or 200 buffers with the points, or would we have the buffers that overlap glue onto each other and become a singular buffer? All right, but let's just go ahead and run it a bunch. So we'd say linear unit meters, side type full, planar, and no dissolve. Let's go ahead and run it. So when we say no dissolve, what we're talking about specifically, this is your output of 15,000 meters. The no dissolve becomes a thing here. There is an overlap. Okay. Let's continue to make interesting and odd buffers. So we'll say it's example 2. Let us try field this time. Field is when somebody said, I want you to use an attribute table column that has different numbers in it. Some rivers will get a 50-meter buffer, some will get a 100-meter buffer, some will get a 200-meter buffer. We're going to use this distance one. Again, I just made the numbers up. And we'll go ahead and leave everything the same, except how about this time we dissolve so we can compare the outcome in this area with the outcome from the one where we have the distance set. Let's go with dissolve all output. So these, I want you to make a note of seeing this line here is significantly thicker than this line. Okay, and this would be, I set this to 30,000 meters, I guess, or this one to 10,000 meters. But you can see that they have been customized specific to the segment of the river system. All right, what others can we test out? Let's say we don't need field. I'd probably leave that. How about we try left? Let's see what happens. So example 3 and run. We turn off example 2. And now you can see if we zoom in, just the left side of the line has been buffered. Again, this is only really makes sense for line files. Okay, turn example 3 off and zoom back out. Make this example 4. Do a few more. Let's see, end type. Let's change that to flat, and we'll zoom in to an end. So now I left left on here. It's just fine. So we have the left side buffered and a flat ending as an example to compare it to. There's your rounded ending at the distance we have set for this, which again I believe is 30,000 meters. Okay, so flat and planar and dissolve. Some other things. Let's see a couple more fun, interactive. We've been messing with lines. Let's do some points. All points. Distance field. We don't have a customized entry for distance for anything, so we've got to pick linear unit, and 15,000 meters is fine. But let's say we try. Let's give you a no dissolve and see how messy this is. Oh, let's change the name. Let's say points. Let's see what's better. Perimeter is missing. No dissolve should be good. All right, hang on one second. Okay, what the problem was, I was trying to reload the buffer tool that was being used for the line buffering with the point system. So I just hit the back arrow, and we just went ahead and reloaded buffer. It's clear now. And let's say all points. We'd say buffer 1 is fine. Linear unit, meters, let's say 15,000. All right, and then we will go ahead and change dissolve type to no dissolve to leave it a bit of a mess, and we can go ahead and hit run. You see it running down here, and it may take a second. Okay, and when I say a mess, you can see here all these overlaps. You see the lines within each individual point now has its own buffer. I'll leave this zoomed in, and we'll change this out, and we can just do a comparison between dissolve and no dissolve, and we'll say dissolve. And our tool has run. This is the no dissolve, and the file that has the dissolve is here. So these are the same things, except one has a dissolve and the other does not. Okay, and our final little trick with buffer you may find interesting is the use of making it go negative. All right, so let's say this purple area, we want a buffer to go inbounds. Instead of buffering out, okay, out of it, we can buffer inside of it. So I'll show you what I mean with a regular old polygon buffer. Number one, let's say chemical spill area. Chemical spill buffer, let's change it to meters and say 15,000. Okay, full planar, all no dissolve, it's fine. Just this would be an outward buffer going away from the chemical spill area. All right, so if we shut everything off, all right, and that's our chemical spill buffer. All right, so like that. All right, and let me change this coloration to government. That's fine. That's our buffer color. All right. Finally, let's try buffer 2 and say negative. All right, and let's see, turn chemical spill back on. And go ahead and run it. See, now it goes inside of it. So chemical spill buffer 2 is actually smaller. The blue area here, this one goes into the buffer. So if you wanted to say, I have the shoreline of the U.S., give me a, I don't know, sea level rise or something like this, 100 meters inland. What are the islands that are going to be affected or something like that? You would definitely want to consider using this negative function. That's generally it for buffer. It's a pretty standard tool, but there are a little bit of tricks here and there. All right. Oh, I wanted to add real quick, there's this final dissolve type. We talked somewhat extensively about no dissolve and then dissolve all output features into a single feature. But there's this dissolve features using the listed fields unique values. All right, and so long story short is I'm not going to run the tool. I just wanted to explain it. So we have rivers listed here. If I go ahead and grab that, what it's going to do is allow you to pick a field, so distance, and basically what this is let's say there's 15 rivers, okay, and 5 of them have distances of 5,000 meters. All right, anything that intersects or overlays or has any type of connection, if they are 5,000 meters, will be dissolved together. All right, if there's another 3 of them that have 3,000 meters, those ones will be dissolved together. Additionally, if we were to have buffers of like schools or government buildings. So if we're talking about like crimes are more severe within 2 miles of schools or a mile of government buildings. If we were to set this up, we could set it up such that the government building buffers will buffer at, let's say, 1 mile and will dissolve together. And then generally in a separate field, the 2 mile buffers on the elementary schools or whatever, they would dissolve together because those are unique identifiers. So as identified by government building or elementary school or something like that. Anyway, I just wanted to add that real quick.